reactive, event source, lean, and there's logs in there somewhere, but no one really cares about logs. I care about logs quite a lot, but I think I'm in the minority there, so hopefully I can make you care about them too by actually giving you a reason to write log lines, apart from because our ops team told us that if we don't write logs, we're not allowed to deploy in production. So I was supposed to be giving this talk with my friend Sleepy Fox, Nigel Reynolds-Moss, but he couldn't be here, so we'll go it alone and see how it goes. If I don't say anything, it's because I'm expecting him to speak and he forgot. And I should warn you, I have a cold, so if I lose my voice halfway through, sorry. And if you have a cold tomorrow, that's my fault. Alright, so let's say we're making a game for the Xbox 2. Right? It's called Fate. Some of you might have heard of it. So we're going to play a game mode called Trials of Anubis, not Osiris. Okay, some of you will play Destiny and get the joke. I actually haven't played Destiny, this was Nigel, so I'm kind of winging this. But I'll explain how it works. So this is one of the most popular game modes in the game, or at least was in the previous version. So we're going to rate the next version. We have two teams, Alpha and Bravo. Each one has 3 players. Each team is trying to defeat the other one, kind of standard, kind of team-based stuff. If you take another player down, they stay out for the rest of the round. They don't revive, but another player can bring their teammates back up, right? If all the players on the team are taken down at once, then that team loses the round, and we go on to the next round, and we play best out of 3. Sound like a game that you might actually play? Who knows? Doesn't matter. We're not actually here to talk about gaming or graphics or anything. We're here to talk about infrastructure. So, phase 1. So this is our architecture diagram right now, right? So we have a game, it goes on a Blu-ray disc, it talks to a bridge, it talks to a scoring component, a gameplay component, a matchmaking component, and a players component. So what happens here is some players log on, they sign up. The matchmaking component notices the players are logged on and it collects them together and puts them into teams. Then the gameplay notices that a match has started and it starts to run the game. So players are interacting, they just they play. Stuff happens. Eventually, someone goes down and the scoring component notices that, so it can recognize that when every player on a team is down, it can increment the team score by 1, and it will also recognize when a team has won the match. And they all talk to a database, which I arbitrarily put in Postgres because I like Postgres. So this is a monolith. I like monoliths. Monoliths are great. It's pretty easy to reason about. But it doesn't really scale past a few games at once, and we want to make a massively multiplayer thing with all of the buzzwords. Right? So let's try again. So what we've done here is we've got still at the game, and now we've taken our servers and we've replicated them. So we have server 1, server 2, and server 3. And we have a load balancer in front of them. And they still talk to the same database because they need to share state, like which players are in the game. So we're deploying many monoliths. It's still quite easy to reason about, but we have a problem where the components are unbalanced. Most of the stuff happens in the gameplay component right now, and like having all the other stuff deployed on every server is just a waste of space. And they still have to share data, which is a problem because we still can't scale, right? So phase 3, we broke everything out into their own containers. So the gameplay is a container, matchmaker is a container, etc., etc., and we can scale them independently, right? And that makes sense. And then they still talk to a central database. So we split this into services because microservices are a thing now, and thought we'd copy them. Communication via the database is working well for the first 20 seconds or so, and then everything goes to hell. And it's also bottlenecking us like crazy, right? This is not working. So phase 4. No database, right? So I think this is a bit interesting. So I haven't blown these up yet. So each one of them represents a container. Each one of them has its own data model, and they communicate over HTTP. right? Because that's how we do services. We communicate over HTTP, they talk to each other, whenever it needs some information. So for example, the matchmaker is asking the players component, how many players have you got available, just waiting to start a game. Okay, you've got 6, great, let's go. Right, we'll create a match. And then the gameplay component will be talking to the matchmaker saying, have you got a match for me, have you got a match for me, have you got a match for me, right? This is how we do things with HTTP. It's a request response infrastructure, right? So the gameplay is also talking to the scoring component. That should be the other way around. Scoring should be talking to gameplay. I can't draw arrows. So the scoring component is talking to the gameplay, going, what happened? What happened? Oh, you knocked the play down. Okay, let's add that to the score. Making sense? Wonderful. Any questions so far? I know that was fast. But we went from, let's go back. We went from one server, many components, to the same components, but now they have their own servers. That's basically what's happened, right? The communication mechanisms are actually pretty much the same. They don't talk over Java method calls anymore, they talk over HTTP. So we've solved that scaling issue and replaced it with a new issue, right? Because I shouldn't have gone backwards, that was a terrible idea, never go backwards. Right. So servers manage their own data storage, and communication over HTTP is now considered lightweight by modern standards. So we use that. And this is what the infrastructure looks like inside one of the components. So this is the gameplay component, right? So it has an HTTP router inside. It also logs all its requests for debugging purposes, and so we actually know what's going on later. We have a game runner which runs a game. It does all the complicated stuff of running a game. We have a scoring client which talks to the scoring component, and we have a matchmaker client which talks to the matchmaker component. Make sense? And it has its own internal database, right? I didn't decide what we're actually going to use for that, but we could use Elasticsearch because, I like the last talk, because it replicates nicely, and because we don't actually need, we don't need to log, we don't need that kind of level of consistency because, if it takes 5 milliseconds for everyone to be in sync, that's fine. You wait, I'll start slamming on Logstash later. So that's kind of what our architecture looks like for an individual server, right? So 4 out of our 6 components are just managing the HTTP stuff, which is pretty heavy. And every service needs these same components, but not really the same components. Right? So they all need their own HTTP router, but it's not like we can just copy it. It's not the same one. They all need to log their requests, and they need to do it properly. They all need to talk to the other services over HTTP, but it doesn't mean we can just replicate the clients. You need a different kind of client for every single other service. And now we're just talking about one game mode in the game, right? So imagine what happens when we're dealing with 10 different game modes. It gets big, right? None of this HTTP stuff will ever make us money, right? It is waste, right? This is stuff that we have to write because it is necessary to make the thing work. But if we get it perfect, our customers won't even know it exists. They will only ever notice when we get it wrong, right? It doesn't ever make us money, it can only cost us money, right? So what if we can do better? Let's make something that works not against our architecture, but with our architecture. So instead of consuming, let's think about publishing events. It means you don't need HTTP servers because you're just publishing an event. You don't need logs because you can just publish all of your events to one store, and then you don't need to worry about individual logging. And you still need the clients, but they don't need to worry about things like circuit breaking if things go wrong, and caching, and back pressure, and all the fun stuff that comes with trying to follow the directive manifesto. Because we're not really removing complication here, right? We're just moving it around. We move the complication from lack of scaling, like that, and that's complication in its own right? To scale, taking a monolith and scaling it is really, really hard. Taking microservices and scaling them are also really, really hard, just in a slightly different way. Who here is trying to scale, who here is using services Service-oriented architecture or microservices or whatever you want to call it is the same thing. Service-oriented architecture doesn't mean JBoss, by the way. So who here is using services in production? Like 6? Really? Okay, cool. How many of you have scaled past one service, one instance per service? 3, 4, 5. Are you the same people? You've actually done it. I'm impressed. What are you using to do that? They're using Mesos or Kubernetes or Docker Swarm or something else? Doing it yourself? Which one?
Kubernetes.
Kubernetes. Anyone else not Kubernetes? I'm curious. I love Kubernetes. I think it's amazing. Anyone else scaling services? I'm really just interested. All right. So this sounds like a solution, but we kind of have a problem, which is that we already rewrote things once to use HTTP. Now we have to rewrite it a second time to publish events instead. This is ridiculous, right? So it turns out, if you're writing any kind of production-ready application, you already publish events all of the time, and you just publish them to standard out, and we call them logs. Maybe you don't publish them to standard out, maybe you publish them to a log file or something. Stop doing that. That's totally not necessary. So we log everything anyway. If we just push them to Fluentd or Logstash, we have events, right? So has anyone else tried this? I'm really curious. We thought we invented it, but we don't really know. Let's do it. Oh, okay, I was supposed to put impressive transition. Thing to do, this one. Can you read that?
Yes.
Who can't read that? Wonderful. So, the first thing I'm going to do is start Fluentd. I'm running it inside Docker because I'm lazy and it makes life easier. I would advise against doing that in production unless you've already done it before, because it comes with things like we forgot to mount the volumes and we restarted and suddenly we lost all the data. Don't do that. It's actually also really easy to run on a server. I just don't want to install 10 different packages on my laptop. Go binaries are nice for that, although then you have to read Go, and that's horrifying. So we have Fluentd running. Now I'm going to start some services. So we have 4 services, I don't know, and I'll show you the Docker compose file actually, and then we can go through them. So we have the player service. This is building from the canned events because I need some fake input. So we're getting 6 players from this canned events service. It's going to read from this YAML file. And it's going to log everything to Fluentd. So Docker is configured to, instead of logging just to standard out, also push everything from standard out to Fluentd. And this is one of the reasons you want to log to standard out, because it's not a dev responsibility to figure out where the logs go. That's an ops responsibility. And they can use pipes. They know how to use Unix. You may not, but they do. Right? And if you are suddenly DevOps, because now everyone in your team is DevOps, you better learn how to use pipes too. Right. We have Matchmaker. Cursor not working. I'll forget it. Okay, so we have a matchmaker, which does the matchmaking. We have a gameplay service, which does the gameplay, and we have a scoring service, which does the scoring. You'll notice they all have the same environment variable. WebSocket equals this. This is because I couldn't be bothered to actually use a real kind of event store and forward mechanism. So I set Fluentd up so it publishes everything on WebSocket. Right? Which means now we have basically an event, like a message bus for free as just part of Fluentd, and it was about 6 lines of configuration. I'll show you. So all I did was it stores type equals WebSocket. I'm pressing the wrong buttons. Right. So what we're going to do is I'm going to start all our events, right? Well, first I'm going to build them because I can't remember if I already did this. If I forgot to do this, we're going to have to wait a long time for npm install because this is all using Node. So amuse yourselves or something. Oh, we're good. Right. So can you read the bottom of that? Close enough. You know what I can do is just drag that, do that, and then do that. And now you can read the bottom, right? Because it's about 6 lines higher. So, I'm going to bring all these services up. I just want to run through the logs. So you see here that every service started and it logs when it starts, right? And everything has an event type. Now players are joining. And we're logging everything as various level of info. All right, 6 players joined, so a match started. And we have the players in teams. And then a match round started. Now the gameplay service has picked up that the match round has started and it's generating some random data. So a player just went down, player went down, player went down. And I don't actually know how this is going to go because it is actually random. Notice here that every single thing has a timestamp, an event type. The severity is less important here, and we can see which service it's coming from. So what all these are doing is listening, and we can just see a match round ended and another one started. All these are doing is listening to fluently on a WebSocket, which took about 20 minutes of configuration and I think 0 coding. And now we have a message bus for free, and all we do is log to standard out, right? So eventually, the alpha team won. And all that was just listening to events and responding to events by printing to standard output, right? Let me show you the code. I think it's very simple and it's fun. So I'll just look at the scoring one because it's the only one that it's fairly simple. So all we do is on a WebSocket message, we pass the data as JSON. You don't have to use JSON, I just did it because it's really easy to demonstrate, but if you want to use something that's a little bit more efficient, go for it. We get the event type, we look up the event type based on the from our dictionary of handlers. If we don't have a handler, then we just don't do anything, but if we do have a handler for that event type, so let's take match started, for example. So here, the scoring service, when a match starts, will create a new match in its own internal in-memory database. And yeah, it's in memory because I was lazy. And set the score to 0 for each team. Make sense? Pretty simple. And we can, and it goes on like that. So if I scroll down a little bit, you can see that when a player goes down, we remove them from our set of players up, and then we check whether we have a round winner. Now, if we check whether there's a round winner, what we do is, if someone wins, then we log a scoring round 1 message with the match ID, the round number, and who the winner was. And that's all it does. All that does is just print a standard out. I mean, you saw the output, it was just standard output, and we had a message bus for free, right? Very simple. I'm going to talk a bit about the logging framework, but I'll get to that later. And these are event types. So in the scoring service, we only have 4 event types. So we have service started, which we have in every service because it's really useful to know when your service started and to log the host name when you do it, so you can actually find it. We log when round is won, we log when a match is won, and we log when we have an error. Did I just hit this? Can you still hear me at the back?
Yeah.
Cool. All right. I don't know how long I've been talking. I actually have no idea how long this talk is, by the way. So if we finish early, let's all go get food. Right. If we finish late, I'm sorry, you're not allowed to eat until I finish.
30 more minutes.
Oh, we're going to finish early. I hope you have lots of questions. All right. Any questions about this code before I move on?
How many dependencies do you have?
2. And they're at the top. We have the logging thing, which itself has 0 dependencies, because I wrote it. And the WebSocket thing, which I don't know, probably has 47,432 dependencies. But if you look at the node modules folder, you'll see 1 million dependencies. So the reason is because using standard JS as the linting library, which has like 4 billion dependencies, but those don't get deployed into production. I don't need them. But yeah, the WebSocket dependency has basically none. This one has exactly none. And I pushed it to npm this morning. So, any other questions? I'm not using left pad, although one of mine does. Let's find out, shall we? No, not using left pad. And of course, these are packaged using Docker because it's easy. Questions? I'm going to move on in 5 seconds.
What editor, what kind of setup is this, what you are using there?
That's Vim with Node-tree on the left.
Node-tree, and the terminal layout was a...
Tmux.
Tmux.
Yeah. Which is really useful because I can mirror on this screen and that screen using Tmux. Otherwise, I don't know how I would be doing this because I'd be looking that way and trying to type, and that would never work. Any other questions? Any questions about the code? It's alright, we're going to talk about code in a second. So let's go back to this. That was an impressive transition, like on the way back, right? So, what's in a log? So I'm very opinionated when it comes to logging. I think, Christ, that came out of my pocket. Almost strangled me. I think a good log is machine readable first, because I can convert from machine readable to human readable, but I can't do it the other way around very easily without writing a lot of really complicated regular expressions. I don't know if anyone's tried to write a regular expression for the Apache common log format. How long did it take?
I don't know.
Days, probably, to get it really absolutely right. I used to ask that as an interview question.
I put memory away
Yeah.
a long time ago.
I used to get people to do that as an interview question, just because it was funny. Don't ask me to interview people. Yeah, log slash can be good. I think Fluentd can as well. By the way, I picked Fluentd because I've used it before. Log slash is fine. I just never used it. So, if you want to actually read your logs, you can do some pre-processing to turn the JSON into not JSON, but doing the other way around is a bit more complicated. Kibana will help you a lot. If you just pump that data into Kibana, it will sort your logs out for you, visualize them, tell you where your errors are, all that stuff. And actually Sentry is a good shout. I really like Sentry. Alright, so what we don't care about when we log, filtering by severity, output time. You know the log4j, SLF4j stuff, which you set the log level and it only prints the log statement if you've configured it to do so, or it doesn't print the log statement if you haven't configured it to do so. That's really annoying. Just log everything and then use Kibana to filter out everything that you don't care about. We don't care about log rotation or even really logging to a file. You know that thing, again, logback or log4j, they'll log to a file for you and they'll rotate them every day or when they hit a certain file size limit. Stop it. Don't do that. Right? If you only have one service, if you have a monolithic service and you're happy for your logs to stay on the same file system, great. That's what Unix pipes are for. Just pipes down and out to your file and then have another process that does your log rotation. This is not the responsibility of your application. Single responsibility principle applies. Your application's responsibility is not to manage its own logs. That is the job of a log manager. We don't care about outputting in multiple formats. We output in JSON or BSON or whatever format you choose. Output in one format, you can convert to others on read, not on write. We don't care that, I really don't want to see a format string for my logs in the configuration because that means all my services could potentially have different output formats, which is completely useless, right? And it could mean that the output format changed last week, which is even more useless, right? Then onto a file. These are all ops concerns, right? So you don't have to care about those. All you have to do is print a standard out and let someone else take care of this. That someone else might be you tomorrow, but someone else. So every event has a type. The structure is determined by this type, right? So if it's a match started event, like I had earlier, I know exactly what the structure is. It has a match object inside it with an ID property, which is an integer. This is a public contract now. It was always a public contract, you just didn't think so before. Logging is always a public contract because your ops people are probably not you. So if they have little scripts to grep through your logs, even if they're not logged in JSON, to run grep and set and get something useful out of there, like, okay, we know the application is going to break in 30 seconds because it just logged this thing saying, warning, warning, everything's going to explode. Right? That's your public contract. If you change that log output, you've just screwed over every other person that was depending on it, and there are probably quite a few, right? And maybe it's just you. but you know, then you're screwing yourself over, and that's no fun either. So you've got to treat it like you treat your Java classes. You know, you define an interface. You don't just change the interface. You know, how annoyed would you be if Oracle changed the Java interfaces every major version of Java, like Scala people do? Like, that's really annoying. So I didn't have it in this example because you know, it's a toy example. But one of the things I've been playing with recently is actually putting a version number in my log. So it's version by event. So I have a schema for every single version of that event, for every single possible log output. So if I change the schema in any way, I have a test case to make sure if I change the schema and don't increment the version, it fails. So I always have to create a new version. And I, sorry, and it means that I can write an upgrade mechanism. So if I get a log item in version 3 and I'm up to version 6 now, I can just run it through 3 functions to get it to the latest schema. It might be missing some information. That means I probably have to have some nulls in my schema. That's okay. And JSON schema works pretty well for that if you are using JSON. So I was using this library called microservice logging, which I wrote with Nigel about 3 or 4 months ago as an internal tool, which we just open sourced. So it's at github.com/YGT, it's the company name, Your Golf Travel, /microservice logging. We're all hiring, by the way. A pitch over. And what you do is you construct a logger with, and it uses dependency injection because it makes testing way, way easier. And by the way, please test your log output with all your event types. You take the event types for 2 reasons. One is so that we can guarantee that you always put an event type in, and the other reason is so you don't accidentally put an event type that doesn't exist out. So you know you can define them all up front. It does another thing where you say .with, and it adds that particular property to every single one of your log output. We found this really useful. It was less useful in this example, but I've got an example here where, for example, if we do request log and we construct a request log with the request ID, then every log line will automatically put that request ID in, so we can correlate very easily. And we also forward that request ID across HTTP calls with a HTTP header so that every service can share a request ID. So that output looks something like this. So the first one was just a startup. It has the service because every log item has the service. And then the request ID is in every request item, which makes it really, really easy to figure out what went wrong when something does go wrong because you can see everything going on. So, yeah. So if you can check that out, that'd be awesome, and send pull requests and issues. There's currently only, there are a few versions in there, only the Node.js version works, so if someone wants to go write the Java version, we'd love to see it. And you can make it type safe, which would be really nice. Oh God, I miss my type system. So, we have a log of all events in the system. This is useful anyway, right? This is, if you're going to log stuff, log properly, log everything that happens. My standard criteria is log anything that doesn't happen in memory, so this is file system access, network access, you know, HTTP request, database access, log anything that takes a long time, like an import job or something like that, log all errors, and log startup, and if you can log shutdown, but it's not necessary. That's kind of the rule list I keep in my head for what I need to log. There are probably more things in your organization that are specific to you that will be really, really useful when you're trying to figure out what broke at 3 o'clock in the morning. I don't know about you, but when I'm trying to figure out what broke at 3 a.m., I'm usually not very awake, so having something just telling me what the problem was is really helpful. So be nice to yourself. It's like, you know, I'm guessing quite a lot of you do TDD. Wave your hand if you do TDD. Oh, about a third, okay. Well, who doesn't write tests here? You can admit it, it's fine. I didn't write any tests for this application. One of the reasons we write tests is because future you will say thank you, right? And it's the same is true with decent logging. So we have real-time reactive behavior across services, you know, and Fluentd is really, really fast because it has to be. So we were getting those events within a millisecond or two. Granted, they're all running on the same machine, but network latency is network latency no matter what you do. The stateless services are completely scalable. The stateful ones, obviously not quite in the same way, but there are patterns. Elasticsearch is a pretty good one. Adding a new service that derives new information, for example, if we want to write any kind of reporting, analytics, any kind of more long-ranking scoreboard, anything like that, requires no modifications to existing services because all the data is just being pumped out there. All you have to do is listen for it. And if we're pumping stuff to an event store, we can even replay old events to make sure everything is up to date, right? So we have a decent model for handling catastrophic failure. Just replay the events again. And yeah, reporting analytics are basically free. This is my favorite. There's no database, right? I didn't need a database to make this toy example. The system we built this for still doesn't have a database. Doesn't need one. The logs go to standard out. We're running on Google Cloud Platform and Kubernetes, so all of the log output just gets collected into Stackdriver, which is basically a wrapper around probably Fluentd, but I don't actually know. I think someone told me that at some point. Those then get stored in BigQuery, so we can query them later, and then we just do a MapReduce of a BigQuery. It's pretty simple. So that wasn't totally scalable as it is. So load balancing is a little tricky, right? If you have stuff in memory, you can get away with it. You need to do sticky sessions. So we can probably load balance across using the match ID in this example. It's not great, and I would definitely recommend using something else. But you can use Redis or Memcached or something like that if you really want to store something in memory state, which is not actually in your service memory, but slightly outside. On failure, all we have to do is respawn the thing and replay it, all events. So, gameplay is a tricky one in this case. This is a real-time system, but for example, scoring, if it went down, we just respawn it with all of the events plugged in already, just replay all of them, and it would be exactly as if it had never gone down at all. There just might be a slight lag while we redo that. We can push events from Fluentd, Logstash to Kinesis, Kafka, if you really want to make that scalable, because obviously Fluentd is still one server. What you can do is create a Fluentd collector or a Logstash collector per service, and then just push all the events to an actual message bus that knows how to scale. Kafka's quite good at that until you try and debug it, and then it's awful. So be wary, but and test it out first. Try and break it first, I guess, is probably the good advice there. If you get any logs that aren't JSON, it probably means you screwed up. You can flag those, just put them into a different queue and manually review them. It usually means an exception got thrown and it didn't get handled and logged correctly. Right? I wrote some very simple wrapper code that just catches all exceptions and then logs them in exactly the same format as everything else, including the stack trace. You really want to make sure you capture the stack trace. If you want to store events, put them in Elasticsearch, put them in Cassandra, it really doesn't matter where they go, right? What matters is you can just do a query over them and replay them whenever you need to. Upgrade semantics are useful to have built into your log store, but not necessary. You can always upgrade on read rather than upgrade on write. It's slightly more expensive if you're playing really old messages, but my experience has been that you don't need to replay old messages very often. It's usually just like messages in the last hour or so, and you probably haven't changed the format in the last hour anyway, so it's not too big a deal. And when you finally really do need a real database, and when I say a real database, I mean one that actually lets you query data, so an SQL database. Mongo does not count. You can still keep your event store, right? And the beauty of event sourcing is you logged all of the events, you have an immutable history. It's an append-only history of every single thing that ever happened in your system. So you have your write model, as I think the DBZ people call it, but if I got that wrong, don't email. And then you use that to populate the read model, which is what you query. So this ties in very well with command query responsibility segregation. So your commands are your events. You write the events to an event store, and then actually Greg Young's event store is quite good for that. And then you can pump the events into a database via some kind of, but by any mechanism that means you're just doing the updates. So your read model is lossy. It doesn't contain old information. You can always move backwards in time just by replaying events from the start. And you can use snapshotting to not have to replay everything if this is a common problem for you. It's usually not a common problem. Okay, it's 11:46. Who's got questions? That was a lot of stuff. I talk fast.
Do you have an example of how you manage to replay in your code?
Not in this one, no.
Okay. This will be interesting.
It's on GitHub, so if you feel like adding one, that'd be cool.
It all seems easy, but the
replaying is necessarily hard. It's one of those things where, again, we're not removing complexity, we're just moving it around. So we move it into this concept of replaying, and it becomes tricky. I think the best way I've seen, and it's not really possible with the current example because it's just just pushing stuff out over WebSockets, is to never replay from the log collector, but just do a query for all events over time. It is slow, and that's normal. Any questions? Okay, well, if you do have any questions and you don't want to ask them right now, you can get me afterwards. You can tweet me, you can email me, you can phone me if you can find my phone number. It's not online, better not be online. If you want to go over the material in this talk again, it's on that website as an essay. So it's exactly the same content, just, or very similar to exactly the same content. If I can just get the mouse. As an essay form. It's quite long. And if you want to play with the code, as I just showed you, it's on that GitHub repo. And I think I made it public, but I should check that now. And I'll put the slides on the slideshow at some point when I remember. And there'll also be links from that same website, talks.samirtalwar.com.
And on the conference website.
And the conference website. And probably a bunch of other places. And I'll tweet them as well, because why not?
Thank you very much.
Cheers.
Yep.